Okay, so today we're going to talk about speed and velocity and the differences between them, and maybe hit a little bit of graphing behavior as well. It kind of depends on how long this goes. So, number one, speed is a scalar, and it tells us distance traveled divided by time spent. So, if you like, speed is, and we usually use the word average speed in front of it. Average speed is total distance over total time. So, for example, if I was to drive home to my parents' house, it's 330 miles, and it usually takes me about 5 to 6 hours. So let's go with the 6 hours to get home. My average speed on this trip is 330 miles over 6 hours, which would be, so 6 goes into 33 5 times, and I have a 3 left over, so I would be averaging 55 miles per hour. Now you say, but the interstate, the speed limit is 70 miles an hour. Yes, that's true, but usually when I have to go home, I have to stop somewhere along the way to get lunch and to get gas, or to get dinner and to get gas. So there are some stoppages in this time. So when I work with speed or average speed, I'm looking at the big picture of what's happening, not the granular details, as they say, not the moment by moment to speed or moment to moment velocity. So what I want to think about here is there is another phrase, instantaneous speed is the speed at one moment in time. And so what we could have on that is, for example, during this trip home, I could be passing a semi-truck, and for one moment, one split second, my speed might be 78 miles per hour. But then once I get around them and go back to the speed limit, it might be 75 miles an hour. Or I might get stuck behind a cattle truck on my way to the home through the rural roads that I have to travel. And in that case, I would have a speed limit closer to 40 miles per hour. Instantaneous speed is the speed at a single moment. Average speed is over the course of a whole trip. Now, as we continue, if speed is instantaneous would be momentary, and average would be over some particular time period, even if it's just a second, let's consider some things we might have to do when we have speed or velocity, distance or displacement. We might want to be able to ask, what was my average speed in feet per second? So we might want to be able to tell something that's a little closer to what we can see in the classroom. Trying to imagine going 55 miles an hour, it's hard to visualize. You have a feeling for what it looks like when you're driving, but as far as seeing it in the classroom and knowing about how much distance or how fast that is, it's hard to think about. So maybe if we change it to feet per second, we'll be a little bit easier to work with. So we call this unit conversions. You will also hear it called dimensional analysis. And the dimensional analysis term comes from the fact that you are going to change the size of the unit, but not the value of the unit. For example, when we go with 55 miles per hour, the miles is in the numerator, hours is in the denominator. And so we're not going to change this from 1 hour, and we're not going to change it from 55 miles. The value is going to stay the same. However, we will want to look at it in a different unit, and over here I want to end up with feet per second. So what I'm going to do is I am going to multiply by something whose value is 1. You may call this a convenient 1. For example, 5 over 5 is equal to 1. 3/4 over 3/4 is equal to 1. 1 yard is exactly the same thing as 3 feet, so that is equal to 1. Yards and feet, there are 3 feet in a yard, so calling it 3 feet or calling 1 yard is exactly the same quantities, even though we're using a different unit of measure. In addition, you could say 60 seconds is 1 minute. That also would be a convenient 1. These things have the same value. Now, these values, 60 over 1 is clearly not equal to the number 1. So what we're doing here is we're not multiplying by the value of 1. We are multiplying by something whose equivalence is the same. So if I was to say 1 day is 24 hours, mathematically the numbers I would use is 1/24. But these two things are equivalent values, meaning they are exactly the same amount with different units, okay? So these are equivalent values. So here, this turns into 1/3. This one is actually 60 over 1. But the idea behind the 1 is to try to get this equivalent value expression like we have when we multiply or divide by the same number. So in this case, what do we want to get rid of? Well, we want to get rid of the miles. So to get rid of the miles, I'm going to put the unit miles on the denominator so that when I multiply across, the multiple with the miles in the numerator and the miles in the denominator will cancel out. In other words, miles over miles is actually has a value of 1. Because 1 mile is 1 mile. Now, what do we want to get to? We want to get to feet. So I need a relationship here, and we know that this is 5,280 feet is 1 mile. Then, that takes care of getting rid of the miles. Now I need something that has an equivalence to get me to seconds. And so what I've got is I've got hours. So this time hours was in the denominator. I need hours in the numerator. So 1 hour is equivalent to 60 minutes. And then likewise, 1 minute is equivalent to 60 seconds. I almost put those on the wrong side. It happens to me too. So the miles have canceled. Now the hours, 1 hour over 1 hour is 1. And we have minutes here cancels out, but the 60 does not go away. The 60 is actually the value of minutes that we pick up when we change from hours to minutes. So in the numerator right now, I have 55 times 5,280 times 1 times 1, so I'm not going to write the ones down, and then 1 times 1 is 1, times 60 times 60. So this gives me a value, once I pull out my trusty calculator, so give me just a second to get over to my trusty calculator, because this one I can't do in my head. 5280 times 55 divided by 60, and 60 is 80 80.6 repeating feet per second. So now we know that saying 55 miles an hour is exactly the same as saying 80.6 feet per second. So in other words, if I'm driving 55 miles an hour, I'm covering about the distance of the hallway along my classroom in 1 second. That would be pretty impressive if I could run that fast. So that's how speed works. Now, remember, difference between instantaneous and average, and what speed is in general, and that it is a scalar, okay? So now let's look at velocity. Velocity is going to have the same pattern, but velocity is a vector quantity, so we need a speed and direction. It also tells us something about how fast we're moving, but in this case it tells us the displacement divided by the total time. Divided by time. So, here's our velocity definition, displacement over time. So, V, and you'll see it sometimes with a bar over it. Anything that has a bar over it, bar over a letter, indicates an average value. So anytime you see a bar over a number, that's indicating the average value. So average velocity is equal to displacement over time. So if I was to do this same trip, I would get exactly the same thing, but I now need to add, whoops, I've still got 55 miles per hour. If I do the same problem as I did above, that would be my speed. So how do I turn it into velocity? Well, I would turn it into velocity by saying 55 miles per hour southwest. Not me coming home, me driving there. Southwest. So now I've indicated to you that if I live here, my parents live 330 miles over here somewhere. So I have gone south and I have gone west. Now, in physics, southwest can actually be a lot of different angles, and so we're going to have to be a little bit more careful with this guy. So when giving directions in physics, when giving the movement direction, we're going to use an angle. And the way we're going to do the angles is like you had done in math or geometry, where you go 0 degrees, 90 degrees, 180 degrees, 270 degrees. So my parents might live down here. I live here. And I would say something like, let's call this 15 degrees. So I would say my parents, my average velocity was 55 miles per hour at 15 degrees west from south. Because the angle I measured, here's south, and I rolled 15 degrees west. You could also list that angle as here's 90, here's 180, so I'll be moving this way. And if this one is 15, this one would have to be 75. So I could also say average velocity at 75 degrees south of west. That would be 75 degrees. Or I could list it at, if I do the whole angle, I'd have 180 plus 75. Here's 180. Here's 75 at 255 degrees. And then I don't have to say south or west or east or north, because we all know that we measure from 0 axis. So 255 would be start at the 0 axis and curl around the circle until you get to 255. Now, we're not going to do a lot of times with this particular piece yet because we're only going to let ourselves go east and west, or north and south, or left and right. So you don't have to know how to do the angles yet. This is a preview of things to come. This is a things in the future preview. So for right now, you just need to know that to give a velocity, you have to have both the amount, the magnitude, the size, and a direction associated with it. Okay, so now let's imagine that I was to go home and come back to my house over a weekend. Let's say I was to go home and come back over the weekend. Okay. And so that means I've traveled 660 miles I made better time coming back because I sped, in about 5 hours, plus the 6 hours to get out there. So in about 11 hours total. Now what is my average speed and what is my average velocity? Well, my average speed will be 660 miles in 11 hours. So that would be 60 miles per hour. My average velocity will be 0 over 11, which is 0 miles per hour. And you're going, why is it 0, Miss Wilson? You clearly drove home and you drove back, so you were moving, so that's velocity. That's how fast you're going. In physics, it's not. It's because I returned to where I started. And if I return to where I started, I have no displacement. No displacement. If I have no displacement, I also have no velocity. Okay, so there's a little bit about speed and velocity, a little bit of unit conversions to refresh your mind on that. And we will be building in our metric units and metric conversions as well, just a little bit at the time. Kind of tease them, work on them a little bit, go away, work on them a little bit, come back. And I will talk to you on the next Pencast.